Hey, what's up, everybody? 8:20. Better get started. So I wanted to show you guys what I've been working on a little bit with forms. Like a long time ago, let me see if I can show you that long time ago really quick. A long time ago, I wrote a library called React Form. Let me just pull that up really quick. React Form was really fun. It's back in the days when we didn't have hooks. I've actually kind of updated it a little bit, but really it was kind of, I wouldn't say a failed attempt at creating a hook library, but it was just my first attempt, at understanding hooks. And, unfortunately the best way for me to learn something is to build a library and bring a bunch of other people along with me. So I had a bunch of users, a bunch of people that loved it. Eventually, I ended up deprecating it because of other libraries like Formic, React Final Form. Those are also great libraries for handling forms. And now that I have been using those for a while and gotten really used to hooks, I wanted to kind of take a stab at managing hooks again on my own. Managing forms again on my own with hooks. So I'm going to show you guys kind of where I started doing that and maybe where it's going to lead. So let's get into some code. Let me see. Let me get rid of my dock. We will go full screen again. So really quick, this is just a little kind of contrived example, like all of them are. For handling some form state in a field. So you see I have some instructions here. So if we refresh, it says try your name, then delete your name. So I'll put my name in, and you can see it's required. And I show the form or the field state underneath every single form input right here, so you can kind of see what's going on. So you can see it's been touched. This field is now dirty. It has some meta, which you'll see when there's an error. That meta gains an error property right there. Is valid is false, but if we put something in, it's true, and is validating is false. Validation counts 27. Pretty cool. Here's an age where we can increment our age, and we have to be at least 10 years old to ride this ride. And Tanner@gmail.com. So this is cool. This is doing some asynchronous validation. So if I put my own email in, it says it's already being used. If we put somebody else's email in, it'll say, yay, great, there's no errors and you can move on. This is a username, so I'm going to try Tanner, and it'll say username is unavailable. I will try another name. It says, hey, username is available, and this is different because we're not getting an error, we're just getting a message, which is pretty cool. This is just some notes. Put that in there. There's nothing really happening right there. It's always valid because there's no validation on it. And this little example kind of looks like this right now. Each field that you see on the page here has a useField hook associated with it. And honestly, we could put these in their own components. Really, we should put them in their own components, but useField is just a hook that I created to help with validation and with form or with field state. So you can see on the name field, I have a validate function that gives us the value, and if there's not a value or there's no length on the value, you just return required. And by default, it will give us an error. It assigns to error when we return from validate. Same thing here, we have to be at least 10 years old. So we return the string, you must be 10 years old. If you return anything falsy, then it just doesn't do anything. It will actually clear the error that you set. The email is a little different. So the email is using an async validate function, gives us the value, and we can do both synchronous and asynchronous checking in the same function. This is something that's very different that I'll talk about later, just in a few minutes. So first we can say, if there's no value, then just return an email as required. Don't even try and asynchronously validate anything. I know this is an async function, but return as early as you can. And then if there is a value, then we're going to try and validate the email. So we say if the email is not valid, we're going to return a message that says, please enter a valid email address. And if both of those conditions are met, then we are going to say, okay, we're checking the email, so we log out the email. Let's open up our console, clear it. You can see when we type in hello@gmail.com, it starts to check the email. And it's interesting because it sent off a hello@gmail.co because that is a valid email address. I mean, at least the regex thought it was, that's checking the email. And then we await a new, let's see, we are just kind of simulating a little server-side call. So this is where you'd actually check the email server-side if you want with your system. But we're going to mock that for now. So we just make a little timeout, and then we say, hey, if the email is tanner@gmail.com, then we're going to return an error. Otherwise, we're going to return false. So your asynchronous function can come back and just return an error if there was one, or return false, which is pretty nice. And then, so let's go down to the username one, which gets a little more interesting. So for username, I'm going to type in Tanner, and it says checking username. And this one is a little bit different. So we have a validate function here, which is doing some asynchronous, synchronous validation here to say it requires a username. But then if the username passes, we're going to perform some async validation here, but we're going to debounce it. This is really cool. Historically, a lot of form libraries force you, either they don't support async validation, which I think is a mistake. And I think it's a mistake because only supporting synchronous validation is an attempt at saying, at just putting more responsibility on you, the user of a library, to implement it. Synchronous validation is easy to reason about. It keeps your library small. There are ways to do asynchronous validation well and to do it right within a library, which is one of the problems I'm trying to tackle. So it will eventually become a requirement for most forms that communicate with a server. Doing any type of like if you want your users to be able to submit their form and know that it's going to work, you need asynchronous validation. Otherwise, you have to let your users enter anything they want into your form and then let them submit it, and then your system checks it on submission, comes back and says, oh, sorry, that was wrong. It's kind of like, well, why didn't you tell me that that was wrong in the first place when I was doing it? So asynchronous validation, I think, is directly linked to making your forms better for user experience. This is one of those scenarios where being able to do async and synchronous validation in the same function is so nice. So right now, this validate function is fairly synchronous up to this point. We check if there's a value, and it says the username is required. So if we put nothing in there, it says username is required. But if there is a username, then we're going to run this asynchronous function, but we're going to do it in a special way. The validate function exposes a debounce method. This is something that I'm actually really excited about and really proud of. This pattern, there's this pattern where you have a debounce function that's specific to your validate function. And you can return a debounced version of this async right here so that as we're typing in the user, it will wait. In fact, we'll up this to 2 seconds. So it will wait 2 seconds to actually try and validate our username. So if we are typing a ton and finally we get done typing to Tanner okay, boom. It says checking username after 2 seconds, it went and fired this off. Well, right now that call takes 1 second. What if it took 2 seconds, right? Watch this. So Tanner, 0, 1, but then I start typing again, right? 0, 1, and then I start typing again, and it goes to check the username, right? See, those calls that were going out for the old versions, for the old values, they may be coming back because they were already fired off, but we're only taking the latest. We're only letting the latest validation attempt actually work. Oh, sorry, I got something in my eye. It's weird. We are debouncing the input from the user, and we're also only performing any of these side effects right here if it's the latest validation attempt that went out. And that's very important. This is something that not a lot of form libraries handle, or if they pass on to you, you have to write your own debounce functions and wire them up to make sure that you're only, sending out your validation when you want it to, or not, smashing your server with requests, with validation requests when you don't need to. And also, if the user is always editing your form or checking different things, in the middle of your promises, you run into race conditions, and you need to be able to handle those. So this debounce function just takes care of all that for you. It's fantastic. I want to show you how that works. And then there's just a notes field that doesn't have anything. It's just like, hey, here's a field. So this was a really fun experiment, because now each one of these useField hooks returns an input that has get input props, and we can just throw get input props onto any input, and it basically just works out of the gate. And then I made this little field meta component here. Let me see if I can show that to you. Where is that? Field meta. It just takes a field, and then it takes the is validating status off of that field, and it says if it's validating, then show checking. If there's an error, show an error, and if there's a message, show a message. And that's the great thing about this meta. Other than error, nothing else is really controlled by the library. You can do whatever you want. So I keep talking about useField, this useField thing as a library that I wrote, and I did, but I don't want you to use this library, and because it's inherently flawed. There's something about this useField library that, although it works, there are issues with this. And if there's something that you'll notice about this example I've written right here, this form, it's that there is no form element on this screen. And there's also no centralized form area where we can handle a submit. Maybe you'd see a form, and then it'd be use form, and you'd have on submit, right? This is the missing piece. All of this stuff down here works so well, and you ask people oh yeah, can you use state to build a field component? Yes, it does. And yes, you can, and it works great. But then when you get to managing all these fields in a singular form, it becomes an issue. I'm going to show you why. So here's our useField hook right here. It's very simple. We have a bunch of initial values that we can pass in, and those get put into these states right here. So we have value, is touched, is dirty, meta, and is valid, and is validating. Right here we have a ref to keep track of the latest validate function that's been passed in. We have an API ref, which is what gets passed back from the hook and also gets passed into the validation functions. We also have a get input props here, which is what gives us our input props. And then we have a little debounce that gets used inside of every single field. This is our debounce function, which deserves its own stream, to be honest. And then here is the run validation function. So the run validation function is pretty awesome, in my opinion. So we wrap it in React use callback so that we get good change detection, from the hook down. But inherently, it's an async function. So instead of trying to do synchronous and asynchronous validation, we just say that all validation is going to be asynchronous. And this presents a bunch of challenges, but it also solves a lot of issues. By just assuming that something is going to be asynchronous out of the gate, helps because it's very difficult to go back to synchronous code that's wired up through everywhere, and try and turn it into something asynchronous. But if we assume everything is asynchronous out of the gate, it can make things a lot easier. So I just assume that validation is going to be asynchronous. So we set validation to true when the run validation function happens. And this is the secret here. What we do is every single time a validation call is made, we create a new unique ID based on the validation count, which is just auto-incrementing. And we use that unique ID to make sure that we are dealing with the latest version of validation that has gone out. So check latest is this little inline function we made to make sure that we are only dealing with the latest function. And wrap for latest is something that just wraps a function and checks to make sure that we're dealing with the latest version before actually executing it. So we make a new error variable and we call the validation function that was given to us, and we pass it the entire API for the current field, which is important. It lets us have access to everything that would be in what's returned from the field right here. That's really nice because normally this wouldn't be available inside of a validation function right here. But it is, because we use a latest validate ref, or we use the API ref right here. So we take set value, set dirty, set meta, set valid, all of these like set things that would be able to happen inside of our API. So all of these setters, set, anything that could be set on our API, and we wrap them to make sure that they don't work unless we are on the most recent, we're operating on the most recent version of the validation that's being sent to this validation function. And then we await the result of the validate function and assume that we get an error back. And then again, we check to make sure that we're on the latest version, right? Because if another version of the validation has gone out, then we don't want to do anything at all. You can see we just want to disregard everything that the user wants to do afterwards because it's out of date. So if it is the latest version, we'll say, hey, we're not validating anymore. And then we do some nice little error checking here. So we say, if the error does not equal undefined, then we're going to do something with it. If the error is truthy, or if there is an error there, then we're going to do this right here. And we say, if the error is a string, like exactly a string, we're going to set that to the error meta. And then we're going to set valid to false. So if error does not equal undefined, but if error is falsy, we're going to do this. We're going to set error to undefined, and we're going to set valid to true. Okay? And then that's it. The only thing that changes throughout all of that function is just the debounce. So whenever the debounce changes, we're going to update the run validation function. We have an effect here that is handling when things should happen with our automatic validation. So we have a validate pristine and is dirty variables in here. So we check to say if the user does not want to validate pristine and the form is not dirty, then we're not going to do anything. Otherwise, if the form is dirty or they do want to validate pristine values, which means that the form hasn't been touched yet, we're going to run the validation with the current value. And we do that every single time value updates. By passing value in right here, we kind of automatically get that in our change detection with the ESLint plugin for React hooks. Then we return the API ref. So I know that's a lot, but it's a very simple implementation of useField that kind of like, it's like a micro API for handling fields, handling form fields. But this use async debounce function is actually pretty cool. I'll explain it really quickly. What we do is we have a ref that we can keep track of mutable things with. We create the debounce function just one time, so there's no dependencies here. And then the debounce function is always an async function that has like a default function and a wait. And then what happens here is we check to make sure if there If there's not a promise, then we want to create a promise, and we want to keep track of the resolve on it. And then if there is a timeout from a previous promise, then we want to clear it and then set a new timeout. So this is doing like kind of the inline debounce. And then this is where we actually try to resolve the function that they sent us. And if not, it rejects, and then we return the debounce promise. So out-of-date promises never actually resolve, which is kind of nice. So there are problems with doing things this way. First of all, there's no centralized form area to handle submissions and to like bring all of these field values together. Like on its own, I love this useField hook because it's so concise. But now once you start dealing with having fields all over the place that you need to bring together into one place, it gets a little tricky because you have to start hoisting state from this field hook up into a form hook. And that's honestly something that I'm actually working on right now. So let's see. I just want to show you really quick. So this was a great experiment. You guys can go play with this if you want. I'll just put this in the chat right now, and I'll also put it in the description. If you want to go play with it or whatever, feel free. But React Form, you know, I'm not fully convinced yet, but I'm pretty sure that React Form is going to be coming back. I've already kind of prepped it. You know, it's React hooks for managing form state and lifecycle. So don't use it yet, but know that I'm working on it, and it's something you should be excited about. So hopefully we'll have some more live streams about this in the future. I hope you enjoyed looking at my useField hook that I built. Be sure to look at it. There's some fun patterns in there that you can check out. And you'll be hearing from me soon about React Form. Thanks, guys.